In a world where identity attacks come from every direction, only one man stands between. No, let's not do voiceover, let's do actual presentation. So, identity attacks today and tomorrow. What is the core topic here? We're going to start from definitions. Identity means a lot of things. They can be attacked in different ways. We're focusing essentially on the identities that are used to create accounts, either for workforce scenarios. So this could be employees, contractors, contingent workers, and so forth. And it's in the context of access to applications and resources, whether they're in cloud or on-prem. And it also includes identities of end users, customers, members, citizens on those customer-facing use cases. The world of identity attacks is pretty broad, so we wanted to focus down a little bit and talk about the different types of identity attacks and what our focus is going to be. There's identity attacks that happen at account creation. This is typically done through identity theft and synthetic identity creation. If you're a bank, you know exactly what we're talking about. It's fake account creation based on real identities for things like tax return fraud or credit fraud of different kinds. Then you have account takeover attacks where somebody has credentials and they have an account, but they get compromised either through credential theft directly or indirectly through credential stuffing, password spraying, or brute force attacks. And then there's, of course, denial of service type attacks that can lead to lockouts, and they are usually a byproduct of credential stuffing or brute force, but sometimes could be the primary motivation. So those two overlap a little bit. And what we're going to do then is we're going to focus here specifically on this credential takeover part. And let's look at the different components on how it's done. The first thing, of course, is credential theft. I list here phishing and spear phishing, but it also includes DNS hijacking, malware, keyloggers on the device, real-time man-in-the-middle attacks, etc. But phishing is the most common one, and spear phishing for high-value targets. The methodology is pretty simple. You craft a site that's designed to fool the user to thinking it's a real one, securing a URL that's similar enough that they don't notice easily. And then you send it to the users by way of text messages, direct messages on Instagram, social media, spray them onto web blog comment sections, YouTube videos, whatever is your method of distributing that. But you usually use some kind of trust there. You pretend to be somebody else to get them to click on the link. Then you capture those credentials and use them either later, which was the traditional method, or right away in real time in the case of those real-time man-in-the-middle attacks. And they have an important part here because they defeat a lot of the MFA as well. And then, of course, the question is, why is phishing and spear phishing still happening in 2019? We thought that we got over this a long time ago, right? Nope. It's still rising, and because it works great. It works great because people have deployed no MFA, or the MFA is too weak. And of course, people reuse passwords, which makes it easy for you to do things like capture them from one side and then try them on others. So this is a leading indicator also to the next one. And then, of course, there's a lack of security awareness, or in some cases, security fatigue, or risk fatigue, or alert fatigue. It's hard to keep employees and folks energized to stay vigilant because you're asking them to do something really hard. Notice subtle differences, on repeating websites where almost always it's the right one. People are really terrible at that. Okay, what about the next one? Credential stuffing has been in the news a lot. This here is pretty simple. You get a big set of credentials, usernames and passwords. You either buy them, steal them, find them on a drop site like Pastebin or Mega.nz. And then you automate. You take those credentials, maybe filter them a little bit, grep out really obviously garbage ones, and then trying them on a lot of sites. You do this by automation. You buy a tool or create a script. This works. And of course, you can try this on all kinds of sites, usually popular sites so that you have a better chance of succeeding. So start on Office 365, LinkedIn, Gmail, etc. Why does this work? It's because people reuse those passwords. People are lazy. They pick one good password and then use it almost everywhere. And the good password is no longer good if it's breached anywhere, and they can be used on other sites. And of course, these sites don't deploy strong MFA, so that makes it problematic. This type of an attack cost Uber, 600,000 pounds because an engineer that had been breached somewhere else had used the same exact credentials on GitHub, and their repo got popped, and then all kinds of privacy lawsuits ensued. So that was not a fun day. This attack can also be stealthy, because if you do it carefully, then each one of these login attempts from this tool will look like a failed login from the user. So it's not obviously on the radar. They may look like normal logins, and the real users won't get logged out unless they get overambitious and try multiple combinations. Next one that is also common here is password spraying. This one is one where you figure out the actual format of the user's passwords on a given site. Identify that username pattern, and it's very easy today because passwords used to be, usernames and passwords were both treated a little bit differently before. Today, the username is really not private information or secret information. It's publicly out there because in most sites today, it's the email that's the username. So email is easy to discover. You just need to drop into LinkedIn and figure out what's the email pattern, name pattern for a particular company, for example. This works the same way because people pick terrible passwords and there's weak MFA, so no surprise there. This can also be stealthy. This type of attack is sometimes known as reverse brute force because here you just pick a bad password and try it across multiple usernames. Which brings us then to the actual brute force attacks where you get a tool or create a tool or buy a tool that makes automatic login attempts by trying many passwords against one username. This is automated and very scalable. This also works because people pick terrible passwords. The passwords here are in the top 100 breached passwords. There are also top 100 most common passwords. The one on the previous slide, which was password that was queued with a little @ and a 0, had been pwned, last I checked, over 55,000 times. So even when people think that they pick something secure, they do a bad job at it. Now, this attack again works because there's either no MFA or weak MFA behind it. So let's take a look at then the chain. If the authentication comes through, and these are the types of attacks, where do they go? If we look at these paths here, we have our applications that are sending authentication requests, mail applications, terminals, and browsers, and they come over different access protocols that have different properties. They support, those protocols inherently support different authentication methods, either basic authentication, username and password only, or modern auth in order to access a service. And here's the problem. Old mail clients that only support POP and IMAP, still widely deployed, whereas more modern mail clients also support ActiveSync, Exchange Web Services, and MAPI. PowerShell is its own thing, and then of course on browsers it's coming over HTTPS. Almost all of this can go through that basic authentication flow where all you need is username and password unless you take steps to block that from being possible. And then the modern authentication is not supported by those older protocols like POP and IMAP. We will come back to this. This is just setting the stage. So, what happens next? This request then comes in to a service that handles the authentication and authorization like Okta. What is the IDP see? From our perspective, we just expose authentication endpoints. They could be the modern auth endpoint here. This is what Okta's sign-on widget uses. So if you go to sign on to Okta or you have a sign-on widget on your own custom site, it goes against this modern auth. And what we see here is a lot of things. We see that username and password. We can see the IP address. We see the user agent string, browser type, device fingerprint, behavior, analytics are possible. We can do MFA. Life is good here. We also have two other endpoints, WS Fed and OAuth 2. Interesting thing here is the WS Federation, because this is what's used when it's delegated authentication out of Office 365. Here all we get is username, password, and IP. This makes it harder to actually detect the attacks. So, with this backside premise, what do you think is the most targeted service today for identity attacks? Any takers? You get a prize, and you get a prize, and you get a prize. Yeah, exactly. It's O365. Why? Because that's where your mail is. Email is gold. Once you pop somebody's email, you own them. The only thing that I'm worried about is email, and I'm worried about enough that I quit Gmail and went to something more secure. It's keys to the kingdom in the sense that you can impersonate the person. It can be a great launching pad. But there's also a more subtle reason than just email is gold on why this is the target first, because it's related to those underlying protocols. There's the more subtle reason. So if you look at how that Office 365 is accessed, everybody wants to first think that, yeah, we just use a browser. And it's modern auth. We can do MFA. We can do our adaptive MFA, risk scoring, behavioral, all those great things. But the wild word of email refuses to die. Some of these clients that are out there, like Gmail app, iOS mail app, the Mac mail app, etc., Outlook 2016, support modern auth. But there's a lot of outliers there that are still widely deployed, like Outlook 2010, pop an IMAP. And lots of third-party mail clients, especially in the Android ecosystem, where there's just like a plethora of them that don't support the modern auth protocols necessarily. As well as some embedded applications that require authentication that can only support those old protocols. So the legacy auth on legacy apps makes things hard. So if you look at it then on the attack frequency, we did some analysis here. How many attacks can we basically detect on the legacy endpoint versus the modern endpoint? And it turns out that looking at the authentication failure rates, 10 times more failures happen on the legacy auth. And it's not just that, there's like accidental mistypes of passwords. This is what they're targeting. Why is that? It's because why would you pick the deadbolt? Here, the modern auth is motion detector lights, you got your Ring doorbell video camera there, and you've got a biometric deadbolt. But the legacy auth is the open side yard gate and the sliding glass door from 1960s with a latch that's broken, like my house. So that's why. Why would you pick the deadbolt? So let's take a look at the landscape then. What exactly is the landscape looking like? We can look here and look at the types of attacks, the goals, like you want to actually compromise the account or simply disrupt the service. We can look at the means of the attack. We can look at the motivations and at the impacts to your organization, either account compromise or account lock. So we have introduced today at the keynote a lot of new capabilities that help you, especially on that modern auth path. But we also have capabilities that are a little bit more subtle. And for that, I'm going to bring up Neha Anand, who's the Group Product Manager, to tell you more about them.
Thank you. Thanks, Sami. That was a great overview. So how many of you have seen one or more of these attacks in your organization? Yeah. It's an asymmetric problem that we are dealing with here. Today, more than ever, it's never been easier and cheaper for someone to initiate an attack, whereas the effort and cost that is involved in detecting, preventing, protecting from these attacks are huge. So we at Okta are focused on building products that can help us reverse this imbalance, make it easy for us to detect and respond, and at the same time make it difficult for an attacker to succeed. Let's take a look at the products that we have today and things that we are working on and will be available within the next 6 months for you to use for these credential-based attacks. Okay. First, we have a global list of blacklisted IPs. This is a list of IPs that our SOC team has identified as malicious, and these are blocked at the router level for all of our customers. Next, you have the option to create your own blacklist of IPs and locations that you have identified as malicious by analyzing Okta system log data or data from other third-party vendors. This is an org-specific blacklist. It's specific to just your org, and any requests coming from these are blocked at the service level. But for those of you who have users who are also signing in from the locations that you're seeing these attacks come from, blacklist is not an option. So you can set up an Okta sign-on policy that denies access to those locations, and the sign-on policy also gives you the option to exclude your users. that is whitelist your users. So you can set a policy that says deny access to location X and exclude your set of users. But a few months back, we realized that in spite of a deny policy in place, users' accounts were still getting logged out. And that was because of when Okta was evaluating these policies. What was happening was, after the user submitted their user ID and password, Okta was first validating whether these credentials were correct or not, and only if these credentials were correct were when we were evaluating the policy. So for an attacker who is trying out different passwords, doesn't have the right password, is not getting this combination correct, and we were not even getting to the point of evaluating the policy. So after a certain number of attempts, the accounts were getting logged out. So very recently, we made a change and we switched this order, we reversed it. So now, after a user enters the user ID, we already have all the context that we need to evaluate the policy. And if there is a match to the deny policy, the access is denied. It gives you two benefits. A, the number of incidents of account lockouts have reduced because now this deny access doesn't really count towards the password attempts made by the user. What happens is the access has been denied, so no matter what you enter in the password text box, whether it's the right password or the wrong password, your access has been denied. And B, the attacker doesn't get to know the access has been denied because we show the same error message that you would see when you enter a wrong password. So they just see that their credentials are wrong. They don't get to know that their access has been denied. So this works great with modern authentication. Let's take a look at what will help us with both modern auth as well as the legacy, the Office 365 legacy protocol-based attack. Okta ThreatInsight. Okta ThreatInsight is our threat detection and response tool that aggregates data across all of our customers, applies patterns to detect credential-based attacks, such as brute force and password spree attack. We then identify the IPs that are involved in these attacks and block them and mark them as risky. So when a request comes in, we check if this is a risky IP. If it is, then we can go ahead and block those requests. If it is not, then it goes through the usual sign-on policy evaluation. So one thing that I want to highlight here is that the set of risky IPs is available to all of our customers, but the action to block these IPs is org-specific. So it's an admin control settings, and you can choose to block or not block these IPs. As the identity provider, we are in the direct line of attack. And I think that is our biggest advantage over other vendors because we get to see these raw events in real time, and with the right tools in place, such as Okta ThreatInsight, we can detect the attacks, and because we are also the access managers, we can take the action to respond to these attacks in real time, and that's our biggest benefit with Okta ThreatInsight. The next use case that I want to talk about is something that many of you would have seen. This is where you have a targeted set of users that are getting attacked frequently. So one example that comes to my mind is where we observed that for one single user, there were 400 different IPs with failed login attempts within a span of 2 to 3 hours. And no points to guess that this was the CEO of the company. Yeah, so you must have observed similar kind of attacks for your orgs as well. So how can we handle these type of attacks? For this, we have our risk-based authentication. There was a demo during the keynote session as well as during the security roadmap session. So about how the feature works. So in short, what we are doing is we are building the normal behavioral profile of the user by looking at the past successful login events of that user. So when a new login event comes in, our risk engine takes into account the contextual data from that login event, combines it with the behavioral profile of the user, and generates a risk score. Based on the risk score, the risk level could be high, medium, or low, and you can set policies to respond to those levels accordingly. So let's go back to my example of 400 IPs. What happens when a request comes in from one of these IPs? So we will know that this IP, this location, this device is new to the user, and the user has not signed in from that before. So the resulting risk score for that IP will be high, and if you have, for that login event will be high. And if you have a policy in place that prompts the user to authenticate using strong authentication factors such as Okta Verify with Push and WebAuthn, your bad user Your bad user will not be able to authenticate themselves and their access will be denied. If it is the right user, they will have access to the factors and they will authenticate successfully and they will be able to access their application. In an off chance, if your factors are compromised and it's actually the bad user who is able to log in, then that's an incident of account takeover. But in this situation, you can use our security automation where the end user will be notified and they can report suspicious activity. When they do so, a bunch of actions can be taken, and you can even pass that information downstream for your incident management and response. When we get notified, we take these actions. In addition to the actions such as killing the user session, we also mark that data as malicious data and make sure that that data is excluded from the normal behavior profile of the user. So next time when we see a request come in from those set of IPs, they will go through this whole process and your user will be secure, the access for the bad user will be denied. You can configure factors that you want to use with risk levels or different criteria that you use in your sign-on policy using Okta Modern Passwordless. This gives you the flexibility to pick and choose factors of your choice. Password is no longer the mandatory primary factor. It is one of the factors among the pool of factors. And this feature gives you the flexibility to mix and match factors for different criteria that you want to put in your sign-on policy. It not just allows you to use strong and secure authentication method, it also makes the sign-in experience of your users simple and seamless. So imagine your user signing in with a simple click of a button using Okta Verify with Push or using YubiKey, or now that we support WebAuthn, they can authenticate using Windows Hello or Touch ID on their MacBook or the biometric fingerprint from the Android device. Last but not the least, make sure that you can reduce the surface area of your attack further by taking care of accounts that are dormant and inactive. So you can set policies that would suspend accounts, inactive accounts, accounts that are inactive for over a certain period of time. There are policies that are available that will scan through these accounts, and if they are inactive for over a certain number of days, the accounts will be suspended. So we talked about a lot of features here. Let's see where they come into picture in the authentication path, the new features. Okta ThreatInsight falls under service level along with the org level blacklisted IPs and locations. And any request that goes past this level, you can apply this, the sign-on policy applies to those, and this is where your network zones, behavior, dynamic zones, and risk scores comes in. You can set the policy to deny access or prompt your user to authenticate using one or more of the factors using Okta's passwordless. And once the user authenticate themselves successfully is when they get to access the applications. You can secure your sensitive applications further by creating an app sign-on policy. You can use network zones to control where these applications can be accessed from. You can use the device context to control which devices these applications can be accessed from, whether managed device or unmanaged device or a certain combination of OS and browser. Similarly, you can set policies around your factor enrollment, reset, and recovery, and control using network zones where a user can enroll for a factor, where a user can reset from a factor. So that can be used using, that can be done using network zones. Okay, let's take a closer look at one of the features that I talked about. So I'm going to give you a quick demo of Okta ThreatInsight. So first of all, this is my admin console, and I need to enable Okta ThreatInsight on my account. For this, we need to go to Security, General. This is where the ThreatInsight setting is, and you have two options. The first option is the first option. When you enable this option, you are only monitoring or auditing the data. So what happens here is you will see a system log event show up every time that there is, every time that we observe that one of your user's account was accessed by an IP that was identified as risky by Okta ThreatInsight. So this just logs, so you'll just get system log event with this option. The other option that we have is it will log as well as block. So this option, which says log and block, will automatically block those IPs as well for your organization. In case there are IPs that we incorrectly identify, say there are false positives and it's your actual user that is logging in from those IPs, you have the option to whitelist those IPs as well, and this is the option, the Exempt Zones option that you can use to whitelist IPs. This is where you just you create a network zone and you can add that zone here. Any of the IPs in those zones will be whitelisted, so they won't be blocked. So I have one created. So this is just an example of a whitelist zone that I've created. So now I have I have enabled block in my account. I'm going to switch to the end user who is going to sign in from an IP that we have identified as risky for ThreatInsight. Just give me a second. Okay, it's a bad IP. So now what happens is when the user signs in, they get this message which says you do not have permission to perform the requested action and their access has been denied. So let me switch back to the admin console and I'm going to switch to the Wi-Fi, which is not risky as per Okta ThreatInsight. And here, when I go into system log, you will see that there is a new system log event here that says request from suspicious actor. The action that was taken was denied. The IP that we saw the access from was the IP information is there. In the details, you can see that this IP was identified for password spray attack, and we denied access for it. And like I mentioned, that in an off chance that this IP happens to be one of the IPs that is not risky for you and you want to whitelist these, all you need to do is from the system log itself, you can click on this, on add to zone, and here I can select the zone. This is the zone that I had whitelisted in my settings, and you can pick either it's a proxy IP or the gateway IP and save. And that's it. So your IP has been added to the whitelist, so you don't have to switch between screens to go and update your network zone. It gets updated directly from here, and that IP will not be blocked. So that's what I have for Okta ThreatInsight for risk-based authentication. If you missed the demo during keynote and the security roadmap session, we have a rerun of security roadmap tomorrow, or you can come talk to us at our booth and we will be happy to walk you through the feature. And now we will have Sami back on the stage to talk about the best practices.
Great. Thank you. All right. So with that, you have now a bunch of tools. Some of them you may have known already. We introduced new ones today, and we reminded you of some of the ones that are available to you. How do you then piece this all together? The first step, of course, is deploy strong MFA. Who here has an organization that doesn't deploy MFA for everyone? We have a few. All right. You go to the Hall of Shame. It's the next door over there. It's hard. We get it. And you have to understand what your user population is and pick the authenticators that are the right ones. Even SMS, that is arguably weaker than not having anything at all if you use it for password reset, because it allows you to do a path that you can't control into your password reset. Even that's the right one for some scenarios, like for example some end user customer use cases where you really have no control over and it's infrequent that you need to do. Email one-time password or email magic link might be a better solution for there as well. But we're really pushing people to go towards the right. If you go to a software or hardware one-time passwords, those are better. The challenge with those is that they are also phishable. If you have a phishing attack that is real-time, they can simply ask for that code, because now, again, you are asking the user to do something that's hard for them, recognize a site that is incorrect site when they're trying to masquerade as a real one. And the attacker doesn't need anything except that credential. So if you have the user hand that credential over, including the OTP, the attacker is golden as long as they have real-time capabilities. Either somebody sitting there waiting for it, or more likely automation. There's a lot of malware that does this automatically now. There's toolkits that allow you to do this. So we're pushing towards the right-hand side. When you go to something like Okta Verify with push, and especially when you go to security keys and device authenticators, the world gets a lot better. One of the key things that happens here is that it fundamentally changes how MFA works. Now, with security key and device authenticator with FIDO2, it is not the user who has to recognize that this is a bad site, I shouldn't give up my credentials. The site has to prove themselves to the security key and to the device authenticator. This fundamentally changes everything because now the attacker can't succeed. If they create a phishing site, you go to the phishing site, there's 2FA, they can't replay this because the device authenticator simply doesn't recognize the SSL certificate of the attacker. Unless the attacker can successfully steal the SSL cert of the organization they're targeting, they can't get in. So these security keys and device authenticators are great. They fundamentally change the dynamic. They do things that computers are great at and humans are bad at. So if you have an option to go towards that direction, we highly recommend it. If you saw our security roadmap, where we have a lot of exciting things coming around there, and that's going, the Web Authent, for example, is in preview this week and in production starting next week. What else can you do except deploy strong MFA? We remember that this is only a good option if you actually are in that modern auth path. Why are you telling me this? This is not where I'm being attacked. Well, let's talk about where you're being attacked. You're attacked on the passwords. First thing you can do is simple step. But most people don't know about this that I've talked to. In Okta, you can block common passwords from being selected by the end user. Today, the list is about 1,000 of the most common passwords. We're just now increasing that about 100-fold to about 100,000 most common passwords, including most common breached passwords. So with a simple click on that, your users can no longer select a password that is weak enough that it would be susceptible to some of these attacks that I'm talking about. So that's a great first step. Make it harder to crack. You can go further, and especially if your organization is standardized on the Chrome browser, and download the Okta's Pass Protect Chrome extension. This allows you to seamlessly and securely have the end user's computer check whether they're typing in the password field is actually one of the breached passwords that have been reported on all the data breaches that Have I Been Pwned from Troy Hunt has been collecting. So it's hundreds of millions, billions of passwords that it's checked against, saying, did you pick something that's already in the breach corpus and now leaked out into the world? And it's seamless in that the user can simply say, no, I'm okay. So it just pops up and goes away. It's completely seamless. You can download it at passprotect.io. Then, of course, it's time to make sure that your end users are participating in their own rescue. And you do that by enabling them to see when something's happening. So new device notification emails, you can enable them and decide that they can know when they're actually logging in from something new. It's not foolproof, but it's getting better. And also, one of the real big ones here that you saw in the demo is that if somebody's resetting their email or password, somebody's resetting their multi-factor credential or enrolling into a multi-factor credential, you can send an email about that as well. The beauty of this is that the first thing that an attacker often does is reset the password, enroll into an MFA to lock the genuine user out. And this can allow you to get that early warning. Your users are now telling you when something suspicious happens right away. So let's go back to these legacy protocols then. The purpose should be, let's sunset these. How do we get rid of these? You start by inventorying all the applications that are accessing your system and Office 365 in this example. And look at the ones that are only capable of POP and IMAP. Put them on the death watch and get rid of them when you can. Have them replaced by more modern alternatives. On almost every platform, this is an option. And that way, the authentication events you should only allow through ActiveSync and EWS and MAPI. This gives you a position then where you can go and start then disabling protocols. So you can, in Office 365, you can actually disable those two protocols. And once you disable those protocols, you can then also go and disable the basic authentication path. Now every authentication in your organization is flowing through the happy path where we can do all the strongest things. Strong multi-factor authentication, all the behavioral and risk-based protections in addition to everything else. And if you can't get there today, we have ThreatInsight that helps with some of those attacks, especially on those legacy protocols. We put together a couple of assets for you so that you can actually take these with you. So the first thing is we have a whole ebook on securing Office 365. It covers all these best practices, and it's available to download from this link. How to federate O365 authentication to Okta, enable the modern auth, disable the legacy auth. There's some PowerShell involved. We apologize. Configure O365 client access policy in Okta, revoke the refresh tokens in Exchange, educate the users, cut off clients. It's a whole cookbook on how to, and some best practices on how to communicate this. A great asset to download. Yeah, this is also available from our website, which was just a shortcut for you folks. Sorry about that. So if you go to Okta website, you can just search for that. You'll find that there as well. It was too long URL for me to put up on the screen. And we also have then another ebook that's this specific topic that we talked about today on how to best practice implement multi-factor authentication, improve your password policies, configure network zones, app config, and have user awareness campaigns. This is also available to you as a free download. So with that, we wanted to open it up and answer any of your questions. So I'm going to bring Neha back up here. And we have here 2 room monitors who are going to be bringing microphones up. So if you just raise your hand, they'll run to you, and that way we can all hear it and it gets recorded as well. We have one here.
Does Okta have a mechanism of recognizing IP addresses that individual organizations mark as non-malicious that may be a mistake and evaluating that so everybody gets the benefit of seeing that type of information?
So you mean a global whitelisting kind of thing, right?
Right.
Yeah.
Okta's not perfect and may get an IP address wrong.
Yeah.
And so if, be it one organization or a number of organizations start marking an IP address as a valid entry point, does Okta see that and say, oh, we need to update this?
So that's a feature that is on our roadmap, and we do acknowledge that that's a requirement that needs to be implemented. Yes.
As of today, if you use ThreatInsight, it's important to remember that although Okta does global look at the IP attacks that are happening and failed authentications to decide which ones go to the block list, each blocking and whitelisting is organization specific. So you then decide whether you want to just monitor that and get system log events or block them. And if there's a false positive, the whitelist applies to you. So that way, if you happen to have a genuine user, but there's actual attacks emanating from that same IP, you can whitelist that for yourself so that the genuine user comes through. But it won't impede any other organization's ability to defend against actual attacks coming from that same IP. This happens often in situations where all the traffic is coming through mega proxies and there's a very narrow number of IPs that get assigned.
Okay. Yeah, but in addition to that, we do want to look at if there are more than one organization that is whitelisting a certain IP, then how do we whitelist that for all of you? Yeah. So.
You have a question here?
Hi. Hello. Could you share a little bit more about how ThreatInsight analyzes the risk of IPs? Is it something internal to each implementation, something that is managed by Okta, or maybe even something that you rely on third-party information to do that? So, for example, whenever I first activate ThreatInsight, what would be the first lists of IPs that it would use to sort of decide that risk?
So we are already collecting data on our production cells. So even if you say enable it today, we already have data from all the other organizations that we have identified as those IPs as risky. And you will have, that will apply to your organization as well. And if you choose to block at any point, today, tomorrow, whenever, whatever information we have at that point will be available to you as well.
There's no training period because Okta is globally looking at all the incoming traffic and then monitoring and saying which ones that are the riskiest. The worst ones we block already on the service level. but we can't block anything that might have any false positives. So the threshold is really high. This gives you that next layer, and you can then choose whether you want to start blocking those as well. So there's no training period. You start using on day one. Everybody gets the benefit.
Yeah.
Any other questions? We have a couple of more minutes. Go ahead.
With the risk profiles that you guys showed in setting the different modes of authentication based on the risky sign-ins and stuff like that, are there plans to integrate that into like the server access feature that you guys introduced today, or the Windows sign-on in general? Say like you could have a scenario where someone's sitting on a trusted network, they can just get a text message code sent to their phone or
No text
Okta
messages.
verify.
No text messages. Kill SMS. Never mind.
Yeah.
But,
Yeah.
yeah, could they just tap approve and then it signs them into Windows without typing a password?
Yeah, so this is V1 of what we are introducing for risk-based authentication, where we are looking at Okta sign-on policy only, but in future we will extend it to other parts of the product as well, like app sign-on or factors, or we will even evaluate if it applies to server access management.
But on the server access, it's important to note that what we do there already has risk-based authentication today. Because on day one, it's looking at your Okta session from this laptop that you have active right now. And if your sign-on policy requires strong authentication to your laptop, before you can go and make a connection to Scale FT, you have to have a live Okta session. So all of your Okta sign-on policies for that DevOps engineer apply. You can require WebAuth and U2F, strong authenticators, to even get into Okta. And then when they have that Okta session live, they can then just, type in, the target machine's name and they're in. So in that sense, since it's not in line between the user and the service and the server, it's really about the context of that user and their session on that laptop right now.
This one
All right.
in the back.
Go ahead. We have one here and then one in the back. Go ahead.
So you are keeping track of risky IP addresses. Are you also working with the partners in the OIN for approved IP addresses? So I know that my partners use these IP addresses. These are okay.
Yeah, so those are some of the IPs that we are looking at and whitelisting those IPs, yes.
We have time for one more question.
Quick one to piggyback off of his question. Sorry about that. How are you handling consumer-based VPN? Because they are used in attacks, right? But at the same time, we do encourage our employees to use VPN when our corporate VPN isn't available. So how are you handling those IPs knowing that, a good chunk of them are used for attacks?
Yeah.
So if these IPs are something that you have already configured as part of your network zones that you trust, we will be treating those as whitelists. So we won't be treating those IPs as, IPs that we are, as any of the other IPs that is not trusted by any of the organization. So if these VPN profiles that you're talking about are, you have a network zone in your organization already, and these are whitelisted IPs, then we will treat those as whitelisted.
But I think your question was also about consumer-grade VPNs. If you're a corporate VPN, if people just have that, then we would treat that as any other access control. So the likelihood of us seeing both genuine users to a corporate portal and attackers that are happening to ride on that same VPN is kind of rare. And if you look at the overall overarching landscape, attackers tend not to like to come through VPNs because that makes them detectable. If those VPN providers are collaborating with law enforcement, they can see their source IPs. They try to be more stealthy than that. They usually use botnets that they can rent or something else than VPNs for the attack. But if there's a lot of attack traffic coming from one VPN exit node that happens to be some consumer VPN, and that raises to the threshold where we see enough of them to block that IP, we would block it. Then your genuine user who was so unfortunate that they had, say, same exact VPN provider that particular day gets blocked, they can contact you and you can add it to a temporary whitelist, for example.
Yes, yeah, okay.
All right. I think that's pretty much time out for us here. So thank you very much.